All right, so now that our enemy can move, let's make him do things like shoot. So we're gonna do a little bit in our behavior tree. I kind of wrote down some notes. We've got like an enemy is gonna see if our player is visible, which we're gonna fake it using a line trace. And then if he is visible, he'll move to a close location and then he'll shoot. And if he's not visible, the enemy is gonna move to a random location and just kind of wander around. So before we do any of that, we're gonna kind of give it like a layout blueprint, like with fake nodes, just so we get an idea of the structure. And then we need to make a projectile class, which will be the ball that the enemy shoots. So first, let's go into our tree and let's lay out kind of how this is going to look. So right now we have find our target, find player location, which is our target. We're going to rename this a find target location, I think. Let's say find target location. There you go. So you can rename these nodes without having to change the name of the task. It's kind of convenient. So what we want actually is a selector, I believe. Maybe not, we'll see. And this selector is going to say, is the player visible? So I'm just going to use wait nodes for now because we don't have these tasks yet. We'll say, is player visible? Which is actually going to be a sequence decorator because it'll be like if they're visible. Oops, let's delete this. I could just add the decorator right now. We'll just do this. Add decorator, blackboard, base condition, and we'll call this is player visible or target. Maybe we should say is target visible. Say target visible. If it is, we probably will have already found them and, found the location, move to. We'll say wait here. We'll call this shoot. And we'll end up moving this radius to something like 500. So he's in shooting range. So we'll say set range as a reminder so we don't forget to do that, which if we forget, we'll just have to do it anyway, so who cares? And then we'll say over here, if player is not visible, we're not just going to wait, we're going to move to. So let's say move to. And we'll go player not visible, move to random location, which we can actually call that event on our enemy. Since we already did it, we might as well, right? Where'd it go? Oh, there it is. Yeah, we'll just do a task that calls this event. Easy, easy. Our work's already done for us. Very cool. Or we could not be lazy and we could copy paste this and put it in a task. Okay, but anyway, either way, whatever you want to do, tell me. Just kidding. Okay, so before we do that, we want to go up a level in enemy. We're going to create a projectile. We'll call this EP. Should we just call it projectile or should we call it enemy projectile? Is there a difference? There is a difference. Let's just call it projectile for now. Oh, what am I doing? We want to create it, so we're creating an actor. BP, projectile. This is an actor class because it's not a pawn, it's not being possessed, it's just spawning into the world, and we're going to give it a mesh. Whoa. So, in default scene root and projectile self, let's add a sphere. It's just simple. Actually, let's make an arrow. Let's call it an arrow. This will be more fun. No, not an arrow. Let's add a static mesh. Sorry, I need to slow down. Take a breath. Change our static mesh. We want an arrow. Come on. What is a field arrow? It's interesting that that material looks like that. It's kind of strange. Can we see that in the editor? Yes, we can. That's kind of cool, sure. A little energy beam, arrow, frost shard. I'm gonna move this mesh back so that if we add a collider, which we're going to right now, I'm just gonna do a sphere collider, although a capsule collider would be good too. So sphere collision, and notice, put that. Technically the hitbox is more like that, but we're gonna leave it with space because we're gonna shrink this down to like 24. That's good enough. So that's our sphere collider. Let's call it sphere collider. We'll create an event there on component begin overlap. So to do that, if you missed it, you go in our sphere collider, you scroll down into events and go to on component begin overlap and click the little plus sign. So that will give us an overlap event, which we'll use later. But before we do that, we want to add a projectile movement component. And this will give us our projectiles like movement, speed, velocity, acceleration. And it's weird that initial speed is set to 0 on here. I don't know if I like that. Let's say like, it's either 2400 or 3200. Let's go 3200. Let's make it fast. We'll say max speed's also 3200. We don't need to accelerate. Rotation follows velocity, sure. So rotation follows velocity is very useful for arrows. So like if you shoot an arrow and it goes up and then it comes like down, you know? Yeah. The rotation will follow the velocity, if that makes sense. Gravity scale, we're going to turn off gravity for now. Not going to worry about bouncing. Velocity, sure, that's fine. Okay, I think that's the basics of that. Let's do a print for fun, and we'll say arrow shot, or fired arrow. You don't fire an arrow. Shoot arrow? Let's just say pew pew. Copy that. I'm gonna make it pink for fun. Okay, basic projectile class. Now we want to be able to shoot it. So in our behavior, or our behavior tree, we have this target is visible decorator. Let's just delete that for now, and like also unplug this. I'm going to unplug that as well, so we just know that this works. We want to make sure it works first. It's usually easier to start with something that works, then break it, versus starting with something that's broken and then trying to fix it, if that makes sense. Let's increase our move to 500, and we're going to create a new task that we're going to call shoot. So in our AI folder, new blueprint task, call it BT task, blueprint base, that's our base class, call it BT task shoot. Probably call it shoot target to be more accurate, but that's okay. Event receive execute AI. So what do we want to do? We want to shoot, and what do we want to shoot at? Our target. Should we feed this task a location of what we're shooting at, or should we feed it the target itself and get the location? It's a question we need to ask or answer. But before we answer it, we have to ask it. So I kind of feel that we should give it a location. Like, why make it harder on ourselves? What do you think? Location? Target location is the location of our target. That's where we want to shoot at. But we actually want to shoot our target. So let's just say target. And we'll get their location and add a thing to it. I don't know how much it matters. Multiple ways to skin a cat. Multiple paths up the mountain. I don't know. Anyway. So again, I click this eye here. Go back to our enemy thing. Let's close out these other things. We'll keep third person character, base enemy controller. We don't need this. And our projectile, and we'll work on our shoot. So here, let's add our task. We want to call it shoot. Now delete this. And our target is target, which we set, if you remember, in find target. We move to a location, target location. We're moving 500 points near that location. And then we're shooting. So now we can get this blackboard key target, get value as object. We're going to cast it to actor. I'm already skeptical in my mind's like, oh, to actor? That's kind of high level. Let's see if we can do this. Yeah, I didn't think so. So let's do get third person character. No, not get, cast to third person character. There we go. And we will you know what's kind of weird is like, because there's a camera looking at me, it's almost like third person. Anyway, that was weird. I'm not an actor. I'm a real boy. Okay. We're getting our location. Mesh or capsule component. Get world location, and that's going to be what we're shooting at. So this is shoot. I did this differently in another project recently, so I'm like comparing mentally to that. I'm like, no, let's do it this way. Okay. So we want to spawn an actor from class. I actually did this in the AI character class, I believe, before, because I just did. So now we're doing this here. It's okay. It'll work either way. And if we run into problems, we'll fix them, because that's what we do. So, projectile. So this is our target location right here. We probably want to like add, I'm going to add, because I have a feeling it's going to get the base of it. So let's just add 50 on the z-axis, so we're shooting towards the middle maybe of the mesh. Maybe we should get the capsule component. Yeah. Maybe. Sure. Since that's technically what we want to hit and not the mesh itself. Okay, we're adding 50 to that. Let's just keep this simple. Keep it simple. We don't want to spawn this here. This is our enemy. That's why. So if you do a shoot event in the enemy class, you could call that from here, because the enemy class already knows where it is. Otherwise, in this task, every time you call the shoot event, you no, that's the same, because you're gonna have to update the location anyway. So anyway, controlled pawn, that's our enemy. We want to get the location, get actor location. That's why I was casting to actor over here, because I was trying to get actor location. So that will spawn our arrow at this location. Again, we're going to want to add to it, because that'll probably spawn at the floor. Let's go 100. We probably want to spawn in front of our character too. So hate to do this because it's like, wow. But let's get forward vector. Come on. Get forward. Huh. Get rotation? Can we do that? Can we get rotation? Get rotation. Get actor rotation. Make forward vector. I know this is a little extra. Maybe not make. Forward vector. Get forward vector. Okay. This is a little bit extra, but to spawn the arrow in front of our character and not like inside of them, which technically would be using a socket if we were doing this with an actual bow. like mesh, but right now we're just doing it in front of the character. We're going to go get actor rotation, get forward vector of our controlled pawn. We want to multiply. We're going to make a literal float. This is our range, or not our spawn location, not our range. Like how far in front of our actor do we want to spawn the arrow? We'll say 100. And we're adding that to this, which we're still adding the 100 to the vertical. So that's actor, arrow spawning 100 or 200, 100 units in front of and 100 units up. Whichever perspective, you know what I mean. Okay, and what are we doing? This is our target. This is our target location. So in our projectile, we probably want to set this target somehow, because otherwise we're spawning in front of our character and we're just gonna shoot at them. We could rotate towards them first and just shoot in a straight line, which would work. Let's just go with that. But like, I like to be able to have my character not facing 100% in line with them and be able to aim with an offset, you know what I mean? But for simple example, we'll just ignore this for now and do a rotation to face target. Rotate to face blackboard entry. Target is target location. No, we want to face target. We're gonna have to create a custom thing, aren't we? So here, we'll use target location for now. Precision of 10, but this is not going to be up to date because as soon as your player moves, they're just going to shoot at the old location. That's okay. We just want an example to work. So once we spawn this, let's just hit finish execute. Success. Excuse me, this wait, we're going to change this to 3 seconds just so we don't have to wait so long when testing. And this is just straight up in here. We don't have the player visibility check yet. Wait, find target, find location, move, rotate to face target location, and then we'll shoot. And in theory, this should shoot directly in front of our pawn. Maybe. We might have to set our actor rotation here. Let's see if that works. I'm going to override collisions, and I'm going to say try to adjust location, but always spawn. And let's hit play and see what happens. Oh, he shoots. He shoots a little too high. Cool. Shooting over the head. Let's turn this to 50. So let's hit play. Test again. If I run, he should, and then I run again, he'll shoot to the old place. 3 seconds. All right, cool. So now in our projectile, we want it to actually work a little bit. So on component begin overlap, we want to do things. So this is where you'll apply damage to the hit actor. So in our third person character, we can also set up something in our capsule component to do things here, but let's create a custom event. We'll call this player hit, and we'll print a string, all caps, player was hit, exclamation points. Do we want it to be green? Let's make it red. Reddish orange. Let's do 3 seconds. Okay, so this will shoot that in our projectile. When we overlap, we're going to check the other actor. Let's cast. All caps. Cast to third person character. It's a lot of casting. We probably want to create like a damage interface system, but that's beyond the scope of this tutorial. So here we're doing third person character. We want to call the function player hit, but only if that other actor is, actually we don't want that directly. I'll say get class. Set that, is that class equal to our third person character class? Then branch. Slide this over. Oh yeah, something I just discovered. So like, say you got these things here, you select these and select that, hold shift and press W and it'll line it up vertically. It's kind of cool. I prefer to have these in straight lines though. But yeah, that's a nice little shortcut. Where are we at? So we're here, get class, if it's equal to their player hit. Let's test that that works. He runs, he shoots, player was hit. Cool. So what do we do when the player is hit? We also want to destroy this actor. We're going to do a delay. Let's maybe not delay. Let's just destroy actor, which is the arrow. Will also destroy it if we don't hit the player. And that'll hit play. We'll test that. So now we should see that the arrow doesn't fly through the player, except it's hitting itself and causing an overlap event. So let's do it only destroy it if it hits the player, which means it's going to go through other objects, which you can deal with that later. Not important to this tutorial. Okay, where are we at? Hit play. Let's make this a little bigger. Yeah, this player was hit. Cool. We can create some VFX if we want, but for now, let's just keep it simple. So now we've got the task of rotating or moving, rotating, and shooting. I had plans to detect, is our player visible, and if they're not, move somewhere else. So now we're going to do the selector, and we're going to put a decorator here, blackboard decorator. We're going to call this is player visible. And this is actually going to tie into a future video, because I think I'm going to make this a series, and we're going to do perception after this. Not necessarily the next video, but soon. Maybe the next video. But before that, we'll fake it. So we'll say is target set. And if result change, we'll just abort self. And where are we at? So is player visible, selector, target is set. If not, we want to do something over here. Let's go find target, because technically we can find target and not be able to see them, if that makes sense. Let's double check that. Yeah, that gets our target. And then we want to move somewhere random. Didn't I say that we were going to use that basic enemy function of move to random, even though it's kind of cheeky and should probably be put in its own task? I think we'll use this. Let's just use this. We don't need to create a new task for that. You could. You don't have to. So we don't even need to find our target here. We just need to move to random location. And let's create a task, which you can go new task here and do blueprint base. I just don't like, I don't know, it feels weird doing it this way. BT task, let's call this move to random. And as always, event receive execute AI. Question is, do we want to take this and then just copy and paste it and add it to our task, or should we just call that? Because if we call that, it's pretty easy. I don't know if that's necessarily good practice though. So like say this, we say move to random. This will work. So this might just be an example of like how you can call events and functions in your enemy class, or any class for that matter. any AI class. But generally, as a good practice, I would imagine it would be a good idea to move this into a task, because say you have a different type of enemy, not a different type of enemy, but like a different type of AI, say like neutral AI, and you still want them to do a similar random move to, then they wouldn't have access to this move to random because they're not a base enemy, if that makes sense. So this move to random is no longer decoupled from the enemy class. So let's be good and let's do the thing. So yeah, I just explained why that was good for you, or why we should do that, and that was good. Very tired. I can tell my voice is fading too. Let's go. We're not that tired. Come on now. Come on now. But our voice is fading. So, what are we getting the world location of? Self, which is controlled pawn. This is getting root component. That's fine. Let's delete these. We'll keep our finish execute. We'll just leave this here. That's nice. Simple move to location, and then we'll just do that. Already done. Super simple. And now we can use this task, this move to random task. Hold on, owner controller goes into here. Wait, why is that getting instigator? Delete this. Plug this directly over here. Okay. So this is nice because we can plug this move to random into any type of AI. It doesn't have to be an enemy. It can be a neutral. It could be an animal, and it'll work. So that is good practice, which we don't always do all the time, because sometimes we're like, it's already there. All right. Enough talking, more doing. In our behavior tree, I'm going to move this here. We're going to call this move to random. And it doesn't need a Blackboard key because it gets the AI's location itself, finds a random location near it, and if it's valid, it'll move there. We're going to delete this, keep this comment just to keep it simple. I'm going to raise these. All right. And so notice we have a selector here. If this player is visible thing is to not be set, it'll fail and it'll go here. And because it's a selector and not a sequence, it won't stop. If this was a sequence and this were to fail, it won't execute this move to random. So now we have to be able to set is player visible. So before we do that, we want to create a find, like a is player visible task. Ugh. All right, I'm going to pause it and go to the bathroom. But yeah, I'll be back. Okay, I don't know if you can see on my shirt, I got this little salsa stain. That's how you know it's legit and I'm the real deal. Because without a doubt, it's either going to be toothpaste or salsa or some sort of sauce. Every time. Every time. Anyway, let's create this task. Also, cheers. And then my brain goes blank. New task. We're going to look at player. I usually don't do this. I like to go in there and type it out manually, but that's kind of, it's easier to do it this way. I should change my ways. Okay, let's say VTD task is player visible. I don't know if that's a good task. That's more like a service name. That makes me feel like we're returning a Boolean value. Let's say look for player. No, what should we name this? Naming conventions are very important. Very important. So, we're checking to see if the player is visible. Check to see if player, yeah. Check to see if player is visible. Is visible. That's a long name. You could call it like check can see player. Check can see player. But we'll go with this. The reason I didn't go with the Boolean type name is because, like I said, once you get a bunch of functions across multiple things and you're like, all right, well, this sounds like it should be returning a Boolean value. So when you're trying to think of what function should I call and I want a Boolean value returned, you start thinking like, oh, is this, and so you type in is in your search, and then if this were to show up in that search and does not return a Boolean, then you just like wasted time trying to find another function. Anyway, yeah, so you kind of got to like mentally organize, and that's why naming conventions can be more important than you might think. Also, it just helps you think through the problems and solutions and step through your code. Okay. Is this necessary? Is any of this necessary? I don't think so. Maybe it helps. Maybe it helps. So I'm going to write a comment so I know what I'm doing, because I'm forgetting everything as I do it. That's called Zen. That's called Nirvana. It's called enlightenment. All right, where are we at? We want to check if we can see player. We can see player. How are we going to do that? Well, we're going to do a line trace from where we are, which is the AI, to where the player is. If no hits, we can see player. Maybe instead of a line trace, we'll do a sphere trace. Because maybe line trace is fine. I guess I'm saying that because imagine it's like you had like an object and it's like this, and it's like you're tracing towards me and it hits this and you're like, oh, I can't see you, this is in the way. I guess a sphere trace wouldn't help that, would it? You'd almost have to do like a multi-line trace, fire a bunch of lasers, and then if 7 out of 10 of those lasers don't return a hit, then you can see. But that's not our problem right now. This is just, we're just faking perception. Keep it simple. Try to keep it simple. Please, for the love of God. Anyway, sorry, I'm trying to have fun with it because it's getting to be a long video. All right. Line trace. No, we want to check if we can see player. Well, we need to know where the player is, so let's get the player. Blackboard key target. Target. And it's going to be Blackboard key selector. Make sure it's visible because we need to set it as the player object. We will get this value as object. Cast it to third person character. Almost need an interface for this to avoid casting so often. Get world location. Capsule component, we'll use that. We want to get our own controlled pawn. Get actor location. We're going to do right click, line trace. I don't know why it defaults to multi-line trace when you type in line trace. That's interesting to me. Let's just do line trace. Excuse me. Drinking that bubbly. That fizzy bubbly. Alright, so get actor location. Let's add to it because we need it to be kind of vertical. 50. Start. We should ignore self. Okay. Capsule component. Get world location. Sure. Trace channel. Visibility is probably fine. Let's do persistent. And branch if there's a hit. I don't even know if we need a success or failure. I think it's a success whether we can see them or not. But if we can see them, we need to set the value that we're using in our decorator, which is player visible, and we're going to set that as a Boolean. And I like my Booleans to say B is, or is player visible? Yeah. Not player is visible, because you could type in B, player is visible, and then, yeah, similar idea, but it's the subtleties matter later on. Okay. And we're going to create another Blackboard key. We'll just call this can see player. Put a B in front of it. You know, it's a Boolean. Put a bird on it. Get this. Make it visible. We're going to set as bool. If we hit them, we can see them. We're going to assume. And if we don't hit them, we'll say we can't see them, even though we probably can, maybe can. I shouldn't say probably. We're just keeping it simple for now. And then event receive execute or success. Hold on. Event. Let's grab our other task. What is that called? Finish execute. I'm going to say success on either, because it's not like not being able to see them as a failure. Like we completed our task, which is just determining if we can see them. Check. Check to see if we can check to see if player is visible. That's a mouthful. Okay. Does this look good? What do you think? Looks good to me. We don't need to do any hit result breakings of. Okay, back in our behavior tree. So is player visible, we want this to be our Blackboard key, B is player visible. So we need to set this. We'll set it after here, because if we set it before, then it will stop executing. So if we check for player visibility here off of this, it'll succeed and it won't hit that. So we want to fail this first. Then we're going to check. I don't like that because we're still going to end up moving to random. Oh, that's fine for now. We'll start by moving to random. Then we'll check visibility. This says player not visible. We're going to assume that the player is not visible in the beginning, and that's okay because we'll make it so they're not visible in the beginning. Blackboard key target is target. Self factor for B can see player is B is player visible. I don't think we need to comment that out. So in theory, this will come down here, fail this test because players visible is not set. Come here, we should move to a random location. Then over here, we'll check our Blackboard key target, which we don't have. We don't have a target. We'll find target, we'll move this, find target up. So this will find the player, and even if we can't see them, that'll set our target, then we'll check if we can see them. Let's organize this. Nice. So once we find our target, target is set, we check to see if player is visible, and then we set player is visible to true, so this completes. If all these complete, the selector succeeds, so it resets, we go back through, we say, okay, this is visible, let's wait, find location, move to, rotate, and shoot. And then that succeeds, and then that spits this back up. Uh-oh. We're going to have this infinitely stuck in here after the first loop. Because once this visible is set, we need to set this here. Which means we need to find the target here. This is why trees are a little tricky, if you ask me. It's much easier to have an example that you're working with and just like, oh, they did it this way, let's do it this way. But we're making this as we go. So now let's test. We go, okay, we find our target. We check to see if the player is visible. Is player is visible is true? Oh no, oh no, oh no. Why even use a selector here then if I'm just going to put this over here? Hold on. Now this is just a sequence. Okay, so we're going to walk through this. So notice how this is a selector, so if this succeeds, it's just going to cancel out. So I'm going to undo what my thinking was. We need another sequence. Put that sequence over here. I move these over here. Hold on. Move that, and I'll show you kind of what I'm thinking. Okay, now we're caught up to where I was when I was thinking. Don't think too much. You'll hurt yourself. So we do this selector. This is the trick right here. So we want this sequence. If we can't see the player, we want to move to the random, right? So in order to make this selector move on to the next one, we need this sequence to fail if we can't see him. If we can't see him, we don't move to random. We just stay where we're at and we'll move to another close location nearby. So to do that, we go into our task check to see if player is visible. And in here where it says success, we're going to make this not success. It's going to fail. So that means because we cannot see, because we can't see our target, will fail this. If this sequence fails, selector does not fail. It moves on to the next thing. If we were to leave that as a success, this sequence succeeds even though we didn't see the target, so we'll never move to the random location because this will exit out. Yeah, totally. We're good. Right? We should test it. Why take my word for it? We probably should have done a little less than this. This is a big jump. All right. Hope for the best. Hold on. Can we open this? Wrong thing. Let's see if we can leave that there. Play. Infinitely moving to random location is not setting. You know what? Did we set our things? We did. Backward key, player is visible. We're setting player is visible. Oh, it's because this isn't returning the hit, right? Why isn't this returning a hit? We're on trace channel visibility. Let's check our third person character, our capsule component. Make sure our collider be colliding. Maybe we should just switch it to mesh. And where? Do you guys see collisions? I don't see collisions. What's going on? There it is. Set to pawn. Trace response. Visibility is set to ignore. Okay, we'll switch it to camera. You can make a custom one, but that's why that's not working. So let's switch visibility trace channel to camera. Test that. Although it might cause problems if it bumps the camera, so let's change that. Let's keep it in visibility. Let's just go here. Collision presets custom, and instead of ignore visibility, we want that to overlap. Okay. Very strange. Re-enable this. Saying false still. Why? Third person character, capsule component. Generate overlap events is set to true. We got a custom collision. It's a pawn type. Visibility is set to overlap. Should we block? Just see what happens if we set block. Strange. So apparently we have to block that, which is very strange. So now we're getting true. He should run to there and then I'll shoot. Shoot. Are we not drawing another? Doesn't seem like that trace is being drawn more than once. Let's check this. Oh, crap. Because player is visible is set to true, we need to reset this to false after we shoot so that we check if it's visible again. This is not the best logic, is it? We should check first. So why don't we just make that a sequence? This is what I get. I always get caught up in these trees. Get one that works and then don't mess with it. All right. Okay, so I figured this out. We needed to move up a level. I'll see if I can undo. Oops. Undo to show you what I changed. So I think we were here, roughly. So what I did was I moved the selector up a level and put a sequence below it. Moved our find target and to check to see if player visible is before this, because we want to do that before. And then we say, okay, our selector pin zone over here. So that, okay, we're like, check if player is visible. If player is visible, then it's true, cool, we go into there. If it's not true, whatever, we go up and then we'll do this. Because if this fails, this will still execute the next thing. So that's good. Something I did notice though, and I've had this issue a lot, I don't know why, but rotate to face blackboard entry sometimes just like hangs. It gets stuck. Like I've noticed this in like 3 projects now, that sometimes this gets stuck. So anyway, we're going to test it. If it does get stuck, we'll have to fix it. If it doesn't, whatever. If it does get stuck, it's not hard to fix. You just manually rotate your pawn in the task instead of using that for whatever reason. Okay, so right here, we're doing the trace. Runs to him, he shoots. If I run over here, does the trace and shoots. If I move over here, somehow you can still see. Now, it should fail the trace. This is where we're getting stuck. Okay, I'm kind of sensing that it's kind of wrong, actually. Because I noticed that he's doing the trace after he runs. We do need to fix this rotate to face blackboard entry. I'm just going to manually do it. This is taking a while. Alright, I'm going to unplug this. If you guys know what's up with that, let me know in the comments, because I've run into this problem. I think many people have. So in our shoot, we're going to create a new task. Should we, or should we just... Hold on. Let's just do it in our shoot task. So we're going to get this. We got our border location. We got our rotation. Get look at rotation. Helps if you can spell. Find look at rotation. Okay. So if you right click and let's say context sensitive is turned on, find rotation, Okay, yeah. Find look at rotation. I was saying get look at rotation, but that was incorrect. So we need locations. And our locations are controlled pawn location, and our target location is third person character. Get our capsule component. We'll do this. It's right here. We already have it set up for us. This is starting to get a little messy. Move this. Let's put this up here. I'm just going to put this up here. Ah! The hour is late. It's not that late. We still have daylight. What am I doing? Slide. Okay. So this will set our rotation. I know this is kind of messy. But it's like, do I want to waste your guys' time setting these things? So now that's our rotation that we want to set our pawn. So can we set active rotation? Yes. This will be kind of rough because it's going to like teleport the rotation instead of lerping it. But for now, this is literally just like an example tutorial. I suppose we should do things better, and we'll probably tune things up in other videos as we go. It'll be like a fine-tuning video would be a good topic. So let's test this. Make sure we're off-centered. Sure. Can you see it from here? Run A. Oh, is it tracing? It's tracing through the wall. Shit. Hold on. How is he able to see us? I'm like so over this. Jesus, it's not letting me run. There we go. Still saying true. So let's make sure that these objects, let's check their collisions. Preset to default. Let's make a new collision trace channel. This video has been going for, I don't know, it doesn't say, 8 minutes. That's not too bad. Project settings. What do you think traces are? Collision? Trace channel. New trace channel. Call it enemy trace. Enemy trace. Default response. Let's say block. So now in here, I think we're going to have to close an X, or yeah. Spell enemy wrong. Can I rename that? Give her that N. Anemone. See anemone. Okay. So save. File save all, just in case. And I'm going to close this. Okay. Start recording. Open those back up. And in here, in our shoot, in our line trace, check to see, we should be able to see trace channels, enemy trace now. So now when we go to base enemy, capsule component, no, not our base enemy, we want a third person character, capsule component. Has enemy trace set to block. Sure. So that means everything should block it, but we only want... Oh my god, no wonder. Now I feel like an idiot. A little tired, guys. Sorry. We do want to check what we're hitting. Do we though? Hit actor, get class. I feel so dumb now. Is equal to third person character. We're gonna branch. I should actually almost get rid of this, but I'll leave it here for now. It's okay. Remove that. If there is a hit, if it is our player, say we do see them. If it's not our player, say we don't see them. Small detail, kind of important, because then if we're just hitting something that isn't our player, we were, as long as there was a hit, we were saying, okay, we can still see him. Like, wow, a little bit of a brain fart there. So enemy trace channel, everything will block. That should be fine. We hope. Famous last words. Whoa. What's happening? Is it because we're doing capsule component? So that's true. False. What's our hit actor? Oh, we're hitting ourself. That's annoying. Okay. So if you hit yourself, which is the controlled pawn, you can go like this. We can add, array add. Let's just promote this. Let's just ignore self. I wish there was a way to do this without having to make it an array. We'll get this, ignore self, actors to ignore. Just to be safe, we're going to clear this anytime we call shoot in case it's somehow still in there. You never know. I've seen some messed up stuff. Okay. Let's try it again. So we have a hit of true. This is now saying, okay, we did hit the player class in theory. Let's resume. Should run towards them and shoot. Okay, let's run away. See if that's true. This time it didn't hit the player, so it should return false down here, which if you go through, it says success failed, which is good because that means we didn't hit the player. Hold on, I'm going to disable this so we can actually see what the heck's going on. Hit play, run. So it should just be running around randomly, yes. So that's what we wanted. Just run around randomly. We did it! Now as we run and shoot, you can disable these debug lines, but they're kind of nice to see the chaos. So yeah, that just about wraps up the first video of our AI setup. We went through quite a lot. We got the basics of behavior trees. We set up a Blackboard. We did different events and functions. We set up a projectile class. We debugged a lot. Like, this is not a normal tutorial in that normally you would go, I or someone would go through, make everything work good, and then come back and just walk you through it. But we did this live, lots of bugs, didn't really use an example. So yeah, I think it was good. I hope you liked it. I hope you learned some things. I hope it didn't feel like I wasted your time having debugging issues. Maybe you were sitting there yelling at me in front of your screen, like, you forgot to check the class. This is the problem. And maybe that was part of the fun. So yeah, I'm probably going to do a series on this. I kind of like doing this AI stuff. I struggle personally with behavior trees. They're kind of like reverse logic-y to me, if that makes sense. So I think it might be good to just kind of go through it. I'm I got assets on the Unreal Marketplace. If you're interested in checking those out, I got some Noid Villager AI asset that is has just recently added a farming and hunting update. So that's pretty cool for like a project, you know, template to get your game started. I also have a magic symbol recognizer, which if you trace a symbol, it will match it to one that exists in a template and score them. So you could say like a fireball will draw a fireball and it'll cast a fireball spell. That one's pretty cool. And also, as of the time of this video, there's like another one on there called the hand, which is more of a top down. And yeah, I've already said too much. We're dragging out this ending of this video. We got this guy chasing me. I should have like made a way to shoot back. So yeah, subscribe. Subscribing helps me. Follow, link, like, subscribe for more. I got more for you. Peace. Peace.